Hello, my precious friends. I really hope that you are doing great. Welcome to today's class. It is our third lesson on the ninth topic of Form 3 work, which is called quantity of heat. As usual, let me comment by giving the quote of the day, which states that fear is temporary, but regrets last forever. Therefore, if you don't choose to overcome your fear, be ready to live a regretful life. We shall discuss that quote at the end of our class today. So, in our previous class, we did look at how to determine the specific capacity of a solid, that is using the method of mixture. So today we want to look at how to determine the specific heat capacity of a solid using electrical method. So to determine the specific capacity of a solid, that is, we are talking of a metal solid because remember there is some temperature change that we need here. So of course a metal will always show us the temperature changes easily because it can acquire the heat or it is simply a good conductor. So to determine the specific capacity of a solid using the electrical method, one, we need two holes are usually drilled on a solid to accommodate a heater and a thermometer. So you can see our heater and our thermometer here. Then the solid is then electrically heated using either alternating current or direct current for a time t. Then the change in temperature will be required. The other quantities that we shall need to measure is the voltmeter reading. We'll also need to measure the ammeter reading, and of course we'll also need to measure the mass of the block, which is noted by M. So the first question that you can be asked here is to name the apparatus that will be required in this experiment and state their purpose. So the first apparatus will need a clock, of course, to detect the time for heating our metallic cylinder. Then we'll also need an ammeter for measuring the amount of current that is used. We'll also need a voltmeter for detecting any voltage that is being used. Of course, we'll also need a heater to supply us with the heat, of course, which is having its rating. Then we'll also need that is a thermometer for detecting any temperature changes. Then that particular solid is usually placed in a lagging material. So the lagging material, its purpose is just to minimize any heat losses to the immediate environment. So once we set up that particular apparatus, we'll use the law of conservation of energy, which requires that all the heat that is lost must be equal to all the heat that is gained. That is provided that no heat or no energy is lost to the immediate environment. That is why we are lagging our content or our metallic cylinder. So from the law of conservation of energy, the electrical energy lost by the heater, because in this case it is the heater which is supplying the heat, therefore it is losing the heat. Then that particular heat is of course gained by the metallic cylinder. Therefore the electrical energy lost by the heater must be equal to the heat energy which is gained by the metal cylinder or the metal block in this particular case. So of course the electrical energy which is lost by the heater will be given by VIT. So that is the voltage of the heater multiplied by the current of the heater multiplied by the time for which that particular metal cylinder was actually heated. So VIT must be equal to heat gained by the solid or by the metal block or by the metal cylinder will be given by mass of the solid or mass of the block times specific heat capacity of the solid or of the block multiplied by the change in temperature for the solid or for the block. Then of course, if you want to find the specific capacity of the solid, you'll simply make C solid to be subject of the formula, so that our specific capacity of the solid will be given by that is the voltage of the heater multiplied by the current of the heater times the time for heating that particular material, then divided by the mass of the solid multiplied by the temperature change for that particular solid. Then there are some certain precautions that must be taken into consideration in order to minimize any heat losses to the environment. So one of the precautions is that the metal block must be highly polished and heavily lagged. Remember, polishing of the metal block simply ensures that there is no heat loss through radiation. Then the metal block should also be heavily lagged. So to lag is simply to cover it with materials which are insulators or materials which are poor conductors of heat, as shown in this particular diagram. Then the other precaution that can be taken to minimize heat losses to the environment is that the two holes should be filled with a light oil to improve thermal contact with the heater and the thermometer. Remember here we said that we usually make some 2 holes. You drill some 2 holes to accommodate the heater and the thermometer. So the 2 holes that are drilled should be filled, or are usually filled with some light oil that is between these particular holes. Remember, those holes can be a source of heat loss. Therefore, to prevent that, you simply put some oil in between those particular holes so that to prevent any heat loss to the environment. So the holes where we have our heater and the thermometer should be filled with some light oil to prevent any heat loss to the environment, hence improving the thermal contact with the heater and of course the thermometer. Therefore, the specific heat capacity of a solid or of liquids can also be determined by use of the method of mixtures or by electrical method. Of course, in the method of mixtures, liquids at different temperatures are mixed and the final steady temperature is usually noted. So to find specific capacity of one of the liquids, you simply take the heat lost by one of the liquids must be equal to the heat gained by the other liquids. Remember, you usually put the 2 liquids at different temperatures. One of the liquid is placed when it is hot, while the other one when it is cold. So the hotter liquid will always lose the heat, while the colder liquid will always gain the heat. Therefore, from the law of conservation of energy, all the heat that was lost by liquid 1 must be equal to all the heat that was gained by liquid 2. Therefore, from the formula, mass of the liquid times specific capacity of the liquid times change in temperature for liquid 1 must be equal to mass of liquid 2 times specific capacity of liquid 2 times change in temperature for liquid 2. We can easily determine the specific capacity of the second liquid. That is provided that we are given the mass of the second liquid, change in temperature for the second liquid, change in temperature for liquid 1, specific capacity for liquid 1, and the mass of liquid 1. So we can make C liquid 2 subject of the formula and of course determine its specific heat capacity. Then in electrical method, a heater of non-power rating is usually used, that is to heat the liquid to a certain temperature. Then the specific capacity is determined by the formula. Heat lost by the heater must be equal to the heat gained by the liquid. Therefore, if the heater, you can be given the VIT, that is its voltage, current, and the time taken. Alternatively, you can also be given the power rating of that particular heater. So if you are given the power rating, you simply take power times time. Remember, power times time will give you the work done must be equal to, or the heat that is lost by the heater, which is given by power times time of the heater, must be equal to the mass of the liquid times the specific heat capacity of the liquid times change in temperature for the liquid. But if you are given the value of voltage, current, and the time, then you can use this formula. So you simply say the voltage of the heater times the current of the heater times the time for which that particular substance was heated. So this will give us the heat that was lost must be equal to the heat that is gained, which is given by mass of the liquid times specific capacity of the liquid times change in temperature for the liquid. Of course, if you make C liquid subject of the formula, you will be in a position to find the specific heat capacity of that particular liquid. Next, at our first example, which reads that a metal cylinder of mass 0.5 kg is heated electrically. So in short, our electric heater is the one that is supplying the heat, therefore it is the one that is losing the heat. Then if the voltmeter reading was 15 volts and the ammeter reading was 3.0 amperes and the temperature of the block rises from 20 to 85 degrees. So if the temperature of the block is rising from 20 to 85 degrees, this one clearly shows you that the metal cylinder is the one that is gaining heat. If a substance gains heat, its temperature will always rise. Therefore, the final temperature will always be greater than the initial temperature. Conversely, if a substance is losing heat, its temperature will always reduce, such that the final temperature will always be smaller than the initial temperature. Therefore, that is in 10 minutes, so that is the time. So we are required to calculate the specific heat capacity of the metal cylinder. Therefore, the heat energy lost must be equal to the heat energy that is gained. So because our metal cylinder its temperature is rising from 20 to 85 degrees, so our metal cylinder is the one that is gaining the heat. Then of course, the heat is being supplied by the electrical heater. Therefore, the electrical heat energy, the electrical heater is the one that is losing the energy. Therefore, electrical energy lost by the heater must be equal to the heat gained by the metal cylinder. That is courtesy of the law of conservation of energy, which requires that energy should be conserved. That is, no energy is lost to the environment. So based on the values that we are given the voltmeter reading of our electrical heater. We are also given the current. Then of course we are also given the time for heating that particular metal cylinder. Therefore, to find the work done or the electrical energy that was lost by the heater, we'll take VIT. So the voltage of the heater times the current of the heater times the time taken to heat that particular metal cylinder. Then so this of course will be equal to the voltage we are given as 15 volts. Then the current is 3 amperes. Then of course the time is 10 minutes. It was heated in 10 minutes. Then the heat gained by our metal cylinder, that is heat gained will be given by mass of the metal cylinder times specific heat capacity of the metal cylinder times change in temperature for the metal cylinder. So this will be mass of the metal cylinder. We are given its mass as 0.5 kg multiplied by specific capacity of the metal cylinder. We are calling it C metal cylinder, multiplied by the change in temperature for the metal cylinder. Remember, we said when we find the change in temperature, we are not concerned with the sign. Therefore, you simply take the larger temperature minus the smaller temperature so that you get a positive value of temperature change. Then you also saw that the temperature change when it is in degrees Celsius is just the same as the temperature change when it is in Kelvin, which are the SI units. Therefore, the temperature change will simply be the final temperature 85 minus the initial temperature. So of course, we convert each quantity in its respective SI unit. We know the SI unit for voltage is V. SI unit for, of course, current is just the amperes. Then we know the SI unit for time is actually the seconds. So because 60 seconds is equals to 1 minute, what about 10 minutes? So that will be 10 minutes over 1 minute multiplied by 60 seconds. That is to convert it into the SI unit, which are the seconds. Then of course, this one is equals to mass is in its SI unit, which is the 0.5 kg times specific capacity of the metal cylinder C multiplied by the change in temperature, which is 85 minus 20, which will give you 65 Kelvin or 65 degrees Celsius. So if I make specific capacity of the metal cylinder subject of the formula, I'll simply divide both sides by 0.5 times 65. Therefore, specific capacity of the metal cylinder will be given by 15 multiplied by 3 multiplied by 10 multiplied by 60 divided by 0.5 times 65. So this will be 15 times 3 times 10 times 60. You'll obtain 27,000. Then 0.5 times 65, you'll obtain 32.5. Therefore, the specific capacity of the metal cylinder will simply be 27,000 divided by 32.5, which will give you 830.8 joules per kilogram per Kelvin. Again, this answer, I've left it correct to 4 significant figures. Therefore, the specific capacity of the metal cylinder was actually 830.8 joules per kilogram per Kelvin. Question 2 reads that a 180 watt heater is immersed in a copper calorimeter of mass 100 gram. So of course, the heater is the one that is supplying the heat. Therefore, the heat that is lost will actually be the heat lost by that particular electrical heater. Then of course, the other substance will automatically gain the heat. So it is immersed in a copper calorimeter of mass 100 gram containing 200 gram of alcohol. Then when the heater is switched on for 0.01 hours, the temperature of the calorimeter and its content rises by 12%. Again, because we are told that the temperature of the calorimeter and the content it rises, it means that the calorimeter and its content is actually gaining heat, because it is only when a substance gains heat that its temperature would rise. Otherwise, if a substance loses heat, its temperature will actually reduce. So automatically, the calorimeter and its content are gaining heat. So we are asked that what is the specific capacity of alcohol? Then we are given the specific capacity, that is the heat capacity of the copper calorimeter as 400 joules per kilogram per Kelvin. So the substance that is supplying heat, that is our electrical heater, is the one that is losing heat. Therefore, the electrical energy lost by our heater must be equal to the heat energy which is gained by both the copper calorimeter and our alcohol. So because we are given the rating of that particular heater, which is 180 watt, we are also given the time for heating that particular copper calorimeter and the content, which is actually alcohol. So the time is 0.01 hours. We'll simply say that we'll use the formula work done is equals to power times time. So the formula that we use depends on the quantity that we are given. For example, in this case, we are given the voltage, the current, and the time, so we used VIT. In this case, we are given the power rating of our heater, which is 180 watts, so we simply use work done is equals to power times time. So is equals to the heat which is gained by the copper calorimeter is given by mass of the copper calorimeter times specific capacity of the copper calorimeter times change in temperature for the copper calorimeter, then plus the mass of alcohol multiplied by specific capacity of alcohol times the change in temperature for the alcohol. Then I substitute the values that I have. The power we are given as 180 watt, which is in its SI unit. The time for heating we are given as 0.01 hours. But of course, we know the SI unit for time is seconds. Therefore, if 3600 seconds is equals to 1 hour, what about 0.01 hours? So that will be 0.01 hours divided by 1 hour multiplied by 3600 seconds. So this is simply to convert the hours into seconds, because we know that the SI unit for time is actually seconds. So the power will actually be given by 180 times 0.01 times 3600 seconds. Then the mass of the copper calorimeter, we are given that the copper calorimeter has a mass of 100 grams. Then we know the SI unit for mass is kilogram, so we'll simply take 100 gram multiplied by specific capacity of the copper calorimeter we are given as 400 joules per kilogram per Kelvin times the change in temperature for the copper calorimeter, and its content was actually 12 degrees Celsius. So if the question says that the temperature rises by 12 degrees Celsius, if it rises by, that is already the change in temperature. That means they have already taken the final temperature minus the initial temperature, or the difference between the final and the initial temperature. That is what we mean by temperature rises by. But if it was the temperature rises from, then that means that it is the initial temperature. Then if you are told the temperature rises to, that means it is the final temperature. For example, in this case, the temperature was rising from 20 degrees. So 20 degrees is the initial temperature, then it was rising to 85 degrees. So that is the final temperature. Then here we are told that the temperature rises by. So by 12 degrees Celsius, it represents the difference between the initial and the final temperature. Therefore, 12 degrees Celsius is already our theta, or the change in temperature, which can be either in degrees Celsius or in Kelvin. So by 12 degrees Celsius, then plus mass of alcohol we are given as 200 gram, that is from the question, then multiplied by specific capacity of alcohol, which is the unknown, multiplied by the change in temperature for the alcohol, which is also 12 degrees Celsius, because we are told that the temperature of the calorimeter and its contents. So the content that is within the copper calorimeter is the alcohol. Therefore, the change in temperature for the copper calorimeter will be equal to the change in temperature for the alcohol, which is still 12 degrees Celsius or 12 Kelvin in this particular case, because this is already a change in temperature. And we said if we are talking of theta, then whether it is in degrees Celsius or in Kelvin, the values will always be the same, as we proved from our very first lesson. Therefore, this will be 100. If I convert 100 gram into kilogram, which are the SI unit, so we know that 100 that is 1000 gram is equals to 1 kg. What about 100 grams? So that will be 100 gram over 1000 gram times 1 kg. Then 4 times 400 joules per kilogram per Kelvin times change in temperature, which is just 12, plus the mass of 200 gram into kg divided by 1000. So that will be 200 over 1000 multiplied by specific capacity of alcohol multiplied by the change in temperature. Then of course 180 times 0.01 times 3600, you'll obtain 6480. Then 100 over 1000 multiplied by 400 times 12, you'll obtain 480. Then 200 over 1000 times specific capacity of alcohol times 12, you'll obtain 2.4 times specific capacity of alcohol. Then if I make 2.4 times specific capacity of alcohol the subject of the formula, I'll simply take 480 towards the left hand side. So 6480 minus 480 will simply obtain 6000. So 6000 is equals to 2.4 times specific capacity of alcohol. Then I'll divide both sides by 2.4 so that I have specific capacity of alcohol being equal to 6000 divided by 2.4. So if you take this quotient, you will obtain the specific capacity of alcohol as being 2500 joules per kilogram per Kelvin. So lastly, I have an exercise which I recommend that you should try at your own free time to gauge the understanding of the concepts that you have just learned. Of course, if you have any challenges in handling any of the question, just feel free to drop a comment specifying the question that you need help in, and of course I'm always here to try and help where possible. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that fear is temporary, but regrets last forever. Therefore, if you don't choose to overcome your fear, be ready to live a regretful life. So the quote is encouraging us to develop enough courage to overcome our fears. Remember that fear is one of the main impediments that prevents most people from pursuing their dreams. Therefore, I'm here to encourage you to overcome all your fears so that you can start pursuing greatness. And lastly, recall that the easiest way of living a life which has no regrets is by taking action even when you feel like you are tired. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. If you know any student or anyone that you honestly think could benefit from this content, kindly share my link to them or refer them to Kind Tuition Academy. Thank you very much. Until next time, this is Kind Tuition Academy.